Okay, you guys, so this is the next video for 2.7, very similar to 2.6 and kind of 2.5. This kind of combines both sections. So now we're going to do absolute value inequalities. So we're going to work with absolute values of inequalities of the form x is less than a, okay? And then we're going to do the form x is greater than a, okay? So let's take a look. So something very similar is going to happen when you have less than behaves like an and statement. Okay, so the less than symbol when you're working with absolute values behaves like an and statement. Okay, so you say, what numbers are less than 3? So we say absolute value of x is less than 3. So this would be the positive version, right? And then over here, we would do the negative version. We would say x is negative 3. But here's the problem. Didn't I tell you guys that when you put the negative over on the right-hand side, it's not like it just magically appears there. You actually divided negative x less than 3. You actually divided by a negative 1. So what that means is you have to change the direction of your symbol. So instead of having to write that out every single time, what we do is we say that if we're going to change the sign on the right, we have to change the direction of the symbol. So now it's like, oops, yeah, it's like that. So when I go to draw my number line, you see here, they have negative or they have positive 3, right? And we shade left. And then they say negative 3, shade right. So what numbers are bigger than negative 3, but also smaller than positive 3? These numbers right here in the middle, okay? So that's why your computer or the screen here shows that this is the solution set. So our solution set is negative 3 to 3, okay? So that's how we're going to do absolute value inequalities. We're going to do the positive version and the negative version, but we're also going to now incorporate the number line to help us. The other nice thing is if you say this is the solution set, you should be able to pick a number in there, some basket of numbers, or you have this basket of numbers that you can reach in and pull a number out and it better work in the original statement. I always go back and test in the original. We're going to be rebuilding our inequalities sometimes, but I always, when I test into the original. Okay. So let's take a look. Oh, and here's how we could write it. Remember, an and statement can also be written like this. So I could have taken this and I could have said x less than 3 and x must also be greater than negative 3. Well, I could just put x in the middle, put negative 3 here and put 3 here, and then just do this. And that is equivalent to that. So now we're combining 2.5 and 2.7. Okay, so just be careful of that. All right, so, and again, this is a preference. Some people prefer to do these problems this way. Some people prefer to do the problem like this instead of doing my positive version and my negative version. And I'll show you that it works either way, but you can do either. So because it's a less than, I know that this is an and statement. So what I can do, I'll show you how the book does it. The book says you can just write x plus 4 less than 6, and you can now do negative 6 over here. And now we have our compound inequality. We're going to add, subtract 4. Okay, so this becomes 0. This becomes negative 10 is less than x is less than 2. Okay, so if we were to draw the number line, we would see that we would have negative 10 here. We would have 2 here. And we would shade in between because this is an and statement. We're saying what values is x? What values of x could we use that would be bigger than negative 10, but also at the same time smaller than 2? Well, that's all this in here, right? So our solution set is negative 10 to 2, or we could also write x such that, and then negative 10 less than x less than 2. Remember, this is set and this is interval. And this is set builder. Okay, so hopefully you're okay with that and you remember that from 2.5. So now what I'm going to do is I'm going to do it my positive version and my negative version. So either way is fine with me. With this method, you have to, the one the book's showing you, you have to identify that this is a less than. So that means you're allowed to do it this way. If it was a greater than, you can't do it that way. So because it's a less than, or because I just want to do it my old way, I'm going to do the positive version. X plus 4 equals, oops, not equals, sorry about that, less than 6. And then here's the negative version. X plus 4 greater than negative 6. Remember, I just changed the direction of the symbol because I put a negative over on the other side. I moved it. So now let's subtract 4, subtract 4, subtract 4, subtract 4. So we have X is less than 2 and X is greater than negative 10. I draw the number line. This one says greater than. Here's negative 10. Here's 2. This one says I got a shade to the right of negative 10. This one says I have to shade to the left of 2. And then once again, we have our solution set of negative 10 to 2 because we know it's an and statement. Okay, so again, we know that less than or equal to for in absolute values is an and statement. Okay, so either way, either method you guys want to use will work. Okay, so now why don't you guys pause the video and give this one a shot. All right, so let's do it the way the book showed you. It's a little bit faster, but I identified that it's a less than or equal to. So I'm going to first isolate the absolute value, which is what I told you you always do. So I have absolute value of X minus 3 is less than or equal to 1. So now I'm going to do the way that they're doing it in the book. So X minus 3 is less than or equal to, here's 1, and here's negative 1. So it's like I put bookends around X minus 3 around the absolute value. So now I solve plus 3 plus 3 plus 3. So now this becomes 2 is less than or equal to X is, oops, this becomes 0, is less than or equal to 4. So now I draw my number line and I have 2 and I have 4. And I know that I use bracket, bracket, and I shade this middle part. Okay, so that means my solution set is 2, 4 with brackets this time because it's less than or equal to. Now, again, you can go back in and check. A number that should work is 3. So what happens if X equals 3? We should get a true statement. So I'm going to take 3, the absolute value of 3 minus 3, plus 6 is less than or equal to 7. So this is 0 plus 6 is less than or equal to, this is our check, is less than or equal to 7. Is 6 less than or equal to 7? Check. So this interval works. Remember, with intervals, they're really nice. If one of them works, they all work. If one of them breaks, they all break. Now, let's say we pick a number outside of there just to see if we're right, like the number 5. So I'll do if X equals 5, right? Because that's to the right of 4. So the absolute value of 5 minus 3 plus 6 is less than or, and remember, when I check, I always go back to the original. So now this is minus 6, minus 6. So now we have the absolute value of 2 is less than or equal to 1. The absolute value of 2 is 2. Is 2 less than or equal to 1? This is false. But we expected it to be false because 5's over here somewhere, right? It's not inside of our interval. It's not part of our basket of solutions. Okay, so this is our solution. And we could check, a bunch. There's 3.7, 3.9. Any of those numbers will work. So this is how you do absolute value inequalities with less than or equal to or less than. Here's one more. Why don't you guys give this one a shot and then pause the video, or I'm sorry, pause the video, give this one a shot, and then we'll come back. Okay, so you guys pause the video. This one, I'll do my positive version, my negative version, just to show you that it still works. So we have 8x minus 3 is less than negative 2. And this is 8x minus 3 is greater than or greater than 2. Now, do you guys notice anything weird? What am I saying? Look what this says right here. 8x minus 3 is less than a negative number. What is special about absolute values? Must always end up positive. Okay. So 8x minus 3, I don't know what 8x minus 3 is, but I know when I put absolute values around it, the final answer, the final result that comes out of there, the evaluation of that will be a positive number. Can a positive number be less than -2. Is that possible? No matter what we put in there for x, will that ever be a true statement? No. So I cannot even do my positive version, my negative version. It doesn't even make sense to talk about it, okay? Because from the beginning, I noticed that we're saying that an absolute value is less than a -2. That's impossible. It cannot happen. So no solution, or I'll just write the empty set, okay? The set of nothing, okay? So that one's actually easy. Now, if you went through and did the positive version, the negative version, and you're like, but professor, I got solutions. Did you check your solutions? Did you plug them back in and see if they worked? Okay, so let me see. Without having to do everything, let me see if I can tell you. Yeah, so in general, when you're doing absolute values, you should always check if the statement, the original statement is even possible. Don't do robot mode. And what robot mode means to me is you're like, well, Professor B said to do positive version, negative version, and you just do that without even thinking. It just becomes a process to you. That process is to help you figure out solutions without, or how to deal with an absolute value. But that process still requires you to think. You can't apply that process to something that doesn't work. Okay. So this is a false statement from the beginning. They should have never asked us this. And it was our job to recognize that it was a false statement. Okay. So now let's do for greater than. So the absolute value is greater than a certain number, A, is now an or statement, right? Oops, they have it here. So this becomes an or statement. So you remember or statements, they're not as picky. You don't have to have it's only where you shaded twice or the intersection. The or statement says we can take two, different solutions. We don't have to just take that in between part. We'll take shading anywhere. So let me show you what that means for this one, okay? And you can't do it like the and statement. You have to do it my positive version and my negative version, okay? So we're gonna take the positive version, which is y plus 4 is greater than or equal to 6. Remember, with the positive version, you just rewrite everything without the absolute values like it wasn't there. And then the negative version, okay? Y plus 4. Now remember, we're changing this to a -6, so then we have to flip the direction, okay? And let's not be in robot mode. Is it possible for an absolute value to be greater than a positive 6? Yes, that's possible. So let's figure it out. So -4, -4, -4, -4. So y is greater than 2 and y is less than, oops, these are 0. And y is less than or equal to -10. So I'm going to draw my number line and I'm going to put -10 over here and I'm going to put 2 there. Now let's shade. This one says that we have to shade to the right, oops, with brackets. And then this one says that this one here says we have to shade to the left of -10. And since this is an or statement, that means that we have to say our solutions are -infinity to -10 bracket union 2 to positive infinity. And this would be our solution. Okay, so that, and now if you want to check it and make sure it works, you could pick something from here. Let's try -11. So I'm going to say the absolute value of -11 plus 4 is greater than or equal to 6. Okay, so remember, I'm testing the original. So this becomes -7 greater than or equal to 6. Oops. So this becomes 7 is greater than or equal to 6. That's a true statement. That checks out. Let's do one from here. Let's say x equals, let's just, this is our check, by the way. This is not required. This is just so you understand how intervals work. Let's do 5. Okay, so then we say the absolute value of 5 plus 4, and again, I'm using this over here, you guys. I'm using the original, is greater than or equal to 6. So this would become 9 is greater than or equal to 6. Is this a true statement? Check, right? So it's not bad at all, right? This is how it works. Now we could pick something outside of this interval. Let's say 0. X equals 0 is not in our interval. That's like right here somewhere, right? That's not in our interval. It should not work. So let's try this. Absolute value of 0 plus 4 is greater than or equal to 6. 4 is greater than or equal to 6. This is a false statement, right? But we expected that to happen because we knew that we were picking something outside of our baskets of numbers, our intervals of numbers that we say work, okay? And remember, I'm only picking whole numbers like 5, 6, 7. You could pick, 5.318 if you needed to. There's an infinite amount of solutions in each one of these intervals. Remember, by you saying that this is a solution, and oops, let me do it in highlighting. By you saying that this is a solution and this is a solution, you are saying that those are all the numbers that possibly work. So we could pick -11, -11.8, -21.7. There's an infinite amount of solutions in each one of those intervals, okay? And this is how we write it, all right? So let me have you guys try this one. Go ahead and pause the video and give this one a shot. All right, so hopefully you guys remember to isolate the radical or the absolute value first. So we have the absolute value of 4x plus 3. And what I did was I minus 5 first. So this would become 0. So we have is greater than -2, okay? Now here's another type of trick question, okay? We have 4x plus 3 is greater than -2. Now think about this a minute. When will an absolute value be greater than a negative number? Well, won't that always be won't that be always? Because think about it, no matter what I plug into here, won't the result, whatever x is, 1.7, 250, -500 million, once I absolute value that, won't it become a positive number? So remember, we're trying to find what x's we're allowed to plug in here that will give us a true statement, greater than -2. Pick any x you can think of in the world, you put an x in there, and you'll get greater than -2. So the solution is in our all solutions, or how do we say it? Yeah, the set of real numbers. All reals. That is our solution, or -infinity to +infinity. So I didn't even have to do any work just because I thought about what the statement was saying, right? The entire number line will be covered. You could also write it like this, x such that x is a real number. That's also how they might ask for it in the book as well. But this means, and this means the same thing. These two are nicer. This is in interval notation, and this is in set builder. So more than likely, you're gonna, in your book, you're gonna have to do one of those two, okay? So please use one of those two when they're answering. And sometimes they'll specifically ask for interval, or sometimes they'll specifically ask for set builder. Please use the correct one. Okay, so let's just do this one last one, and then we'll call it a day. So I'm gonna isolate the +5 first. I'm sorry, I'm gonna isolate the absolute value first. So x over 2 minus 3 is greater than, what is that, 3? So that's not a trick problem, right? The absolute value can be greater than a 3, and it's not always. There are some numbers that wouldn't work. So we have to do it like we did before. So we're gonna do the positive version. X over 2 minus 3 is greater than 3. And then we're gonna do the negative version over here. X over 2 minus 3 is less than -3. Remember, because I changed the direction, remember this is an or statement, I changed the direction, I now have to, or because I changed the symbol to a negative on the right, the right of the inequality, I have to change the direction of the inequality. So now we do +3, +3, +3, +3. We now have x over 2 is greater than 6. So then we'll end up with times 2 over 1 times 2 over 1. So this will be x is greater than 12. And then this one will be x over 2 is less than 0. So this will be x is less than 0. So now when I draw my number line, let's do 0 and let's do 12. Okay. And let's just do the shading. So the shading to the left of 0 with the parenthesis, and then a shading to the shading to the right of 12 with a parenthesis. So hopefully you guys got something like this, and we know our solution set is -infinity to 0, union 12 to infinity. Remember, union is the way that we connect two statements that we want to say both of them are solutions, two sets. This is how we connect sets. Okay, so that'll be your solution for this one. And these are standard test questions. This is what you're going to see in the homework. So hopefully this video helps you guys with that. Please let me know if you have any questions in our meeting times, but that'll do it for today. Thanks for watching.